Hi, this video is just to show you how to do the multiple regression portion of the homework 4 assignment in Excel. If you go to the assignment, before we get to that, these numbers I'm working with have the same variable names. The numbers are completely different. The relationships are different. The variables to include in the analysis will be different, but the same steps could be followed. So you look at the assignment. The first step says decide which variables to include in your analysis as independent variables. Possibilities are magazine, newspaper, gas, personnel, gifts, price, and promo. Any or all of those may be used to explain sales. We need to figure out which ones we can use with linear regression. In this case, let's look at it without transforming the variables. If you look at the Excel tutorial document on Blackboard, it has some extra steps that would generally be good to follow. Not necessary to follow for the assignment, but for your own benefit, you may want to follow them if you will be using Excel for regression in the future. Or you may just want to save the document so you have it if you do need to use Excel. You might use it in your job sometime, and it'd be good to know how to do it, I'm sure. Okay. So the first step is to look for a linear relationship between the independent variables and sales. We'll do each one independently, so we'll need to create 7 different scatter plots. There's a shortcut you can use to do this, which I will show you now. Things are slightly different, look slightly different in Excel 2013 compared to 2010, which I'm using, and hopefully you'll be able to figure it out. So the first thing you want to do, go to Insert, find the Scatter Plot button, the one with no lines, move that somewhere where you can still see all your numbers, right-click on that plot, and say Select Data. If you select the data first, sometimes Excel tends to put sales on the x-axis and the other variable on the y-axis. So watch that. We want the independent variable on the x-axis and sales on the y-axis. So right-click anywhere in your chart, click Select Data, click the Add button, Series Name. Let's just click on the name of the potential independent variable, in this case magazine advertising. X values will be all the values of magazine advertising for the 89 or 91 months that we have data for. An easy way to select this, click in the top number, the first number. Don't include the data label in your selection, or it will mess up your whole plot, your whole chart. Hit Control Shift, and the down arrow goes to the next blank in your file. You can leave out the last one that's for forecasting. So it'll be 1 through 89. So that's selected sheet 1, cells D2 through D90. Y value should be sales. Let's delete what's already in there. Click on the first number in the column, not the label. Control Shift and down. Say OK. Say OK again. We now have a plot labeled with the label we created. This is magazine advertising dollars. This is our sales. Is there a linear relationship? I took off that label because it was redundant. But you could leave it if you wanted to. We've got all these lines that kind of get in the way of looking at it. I'm going to delete those. Not necessary. How about your data points? Is this a linear relationship? Let's just add a trend line. Excel can do it for us and see, is there a line that will kind of fit through the middle of these data points? Right-click on any of the blue dots or whatever color they are, one of the data points. Click Add Trend Line. Make sure linear is selected. Hit Close. And then you have a linear trend line. You can see that this goes about through the center of all these dots. If we were to take the top half of dots and flip them over onto the bottom half, you can see they would line up pretty well. They'd match up pretty well. That is a linear relationship. Now we have 6 more to create. Do we want to create a separate chart using all those steps? We could, but it's a little bit unnecessary. An easy shortcut, select your chart, hit Control C to copy it, click below your chart, hit Control V to paste it, and you see we have the exact same chart. That doesn't do us much good. Click on any of the data points, right? And you can see there's a green square, that's the label. Let's move that over to newspaper. This purple square give us our X values. Let's get this 4 arrows and drag that over here. Make sure, what I accidentally did there is I had it over the label. You don't want that to happen. So it's over the numbers here. Get the 4 arrows, click with your left button, drag over, make sure it does not cover up the words. You can see up here it says C2 through C90, E2 through E90. That's what we want to see. So you can see it updated everything, including our trend line. Linear relationship. Let's copy that again. Paste it. Click on a data point. Go from newspaper. Let's have one that looks at gas. Move both of these squares over. Our chart has been updated. That's what we wanted. Copy that again. Paste it again. Select a data point. Move this over to personnel. Now we have that. Let's just copy the same chart. Select a data point. Go from personnel to gifts. Move that over. Okay. Got that. Let's put another one here for price. Another one for promo. Click on a data point. Move everything over to the price column from the gas column. We already did personnel and gifts. So look at price. You can see that. Go to this one and let's move that over to gifts or promo. Sorry. And I have 7 charts fairly easily created. They all have a label so we can see what's what. Let's check for linearity. This line goes right through the middle. Same here. Again, if you could take the top half of everything above the line, cut it off and flip it over and it kind of matches up with what's below, you're looking good. That's a linear relationship. This is close enough. Maybe a little bit off here in the lower range. Personnel. You'll see. There's a lot of blank space on this chart. Maybe it's easier to see without that. You right click on the axis, hit format axis. This will actually come to the right of your chart in the new version of Excel. But you could change this minimum from 2.9 to, let's say, 2.95. And change this one to 3.12. So you kind of zoom in and maybe see a little better what's going on if necessary. Probably not necessary. This one, same thing, fairly linear, maybe close enough. This one you can see a curved line would be a much better fit to the data. Price may be hard to see, but again you could just zoom in, format the axis, and instead of, let's say, from, I don't know, it's like about 9,500 to about 12.5, and you can see now it's very clear that that's right in the middle. All right, promo. In your homework file, you will find one variable, potential independent variable, that has a nonlinear relationship with price or with sales. Take it out. In this example, it's gifts. In your homework, it is a different variable, but there's only one. This should be fairly obvious. So here we say gifts isn't relevant. Move it out of the way. In Excel, your independent variables need to be next to each other. Don't have any blanks. Okay, next step. Independent variables should not be highly correlated with other independent variables. It's hard to distinguish the impact of each of the separate variables when there's a high correlation. So you want to, if there's a high correlation between two variables, take one of them out. How do you do that? Go to the Data tab, find Data Analysis. If you do not see Data Analysis, go to File, Options, Add-ins. This should say Manage Excel Add-ins. Hit Go. Check this box that says Analysis, and then hit OK. It should install without needing a disk or anything. It should just install. I already have it, so I'm going to skip that. Data Analysis, click on Correlation. Input range, all of the potential independent variables. We already took one out for being nonlinear. We would not worry about finding the correlation between that and others. Make sure you select the data labels in this case. Hit Control-Shift, right arrow, and down arrow. If there are blanks on either side, you'll select the range that you want to. Click the button marked labels, say OK. You get this sheet. Make it easier to read. What I recommend doing, go to your Home tab, make them in comma format. You can add a decimal point if you want to. It's not necessary. What we would consider highly correlated, according to the homework document, is anything with an absolute value greater than 0.85. So 0.86 or negative 0.86, highly correlated. In this case, we have one, personnel and gas are highly correlated. Let's highlight that for you. Basically tells us if the gas price increased by 1%, the number of personnel has decreased by approximately 1%. Proportional changes, not in units but in proportional. Right. So what this says is we cannot include both personnel and gas in a regression analysis. How do you know which one to include? Run two separate regressions. One would include magazine, newspaper, gas, price, and promo. The other include magazine, newspaper, personnel, price, and promo. Which one's better? See the one that has the higher R squared, or if one of these variables showed a non-significant, a high p-value, anything above 0.05, leave that one out and use the other one in your analysis. Let's use personnel just for this purpose of the example. Okay, so that's step 2. We want to use personnel. We do not want to use gas. Let's move gas out of the way. Move it over here. Delete the blank column. We're ready to do our regression analysis. Go to data again. You'll need the data analysis. Pick regression this time. Input Y range is going to be your sales. Make sure you select the label. It makes it easier to read the results. Otherwise it would say variable 1, 2, 3 instead of having names. Click in cells, Control Shift, down arrow will select everything you need. Select through month 89, 88 or 89, the last one before there's a blank. Okay. Input X range, all of our independent variables. Magazine through promo. Select all of that and all that. Select the entire range. Click labels so you can read your results. It says there are labels in the first row, it's not all numbers. Click residuals. This will help you in the forecasting portion. It will do the forecasting for these first 89 observations, which means you'll need to make 3 forecasts. And you say OK. You get your output here. To make it easier to read, I would select the columns, get this double arrow and double click to resize. I would also go to the Home tab and just go in comma format. We're going to lose some of the details. Any calculations we are doing, let's refer back to these specific cells and not try to type them in so we don't end up with rounding errors. And you might want to go ahead and resize those back smaller again. You may notice they print confidence intervals twice, so these last 2, we could delete those. They're not necessary. Doesn't matter if we leave them on. I'll highlight some of the important things that we want to look at in this output. Those are the most important things. First thing we want to look at is, are all of our independent variables significant? P-value lower than 0.05. We go through this and we see there's an 87% probability that magazine advertising had no impact on our sales. We can look over here at this confidence interval and we can say we're 95% sure that this variable should be somewhere between negative 0.55 and positive 0.46. If we spend more in magazine advertising, either it hurts our sales or it helps them, which means probably it does neither. So the best thing to do in forecasting is to run a new regression without magazine. Take magazine out because it was non-significant. Now, other uses of regression analysis, you may want to leave that in, but for forecasting, there's no reason to have a non-significant variable included. So we'll go back to sheet 1 with our data. Let's take magazine out. It had no impact. We could actually leave it in because all of our independent variables are still next to each other. Okay, so go back to data, data analysis, regression. If you're doing this in the same sitting, it will have everything selected that you previously selected. So all we need to do, instead of going D through H, let's just change this one letter to an E. If you had to move things around differently, you may have to reselect those. Labels are still selected, so is residuals, new worksheet ply. Say OK. We get a new analysis. Let's change this to just comma format to make it easier to read. And let's do this. Compare that to sheet 3. R squared was 63%. R squared is still 63%. Newspaper was 1.76. Now it's 1.75. So that did impact these things. So this is a better analysis. Let me go back here and highlight what's important to look at. Most important from my perspective. Again, we have these upper and lower 95% intervals duplicated. Maybe it's confusing. You may want to just delete that. So what do we have here? R squared is 0.63. Change this percent. That says, I will change that to a percent format just to make it easier to look at. This says, we have explained 62.9% of the variation in sales with this model. Pretty good, not perfect. Now if we were to go back and reanalyze, put gas back in, take out personnel, remember those were our correlated variables, we might see a slight difference. I believe in this example, R squared might go down to, either goes down to 57 or up to 67. I don't remember. We won't do that for purposes of brevity. But this is important to look at. It's okay for forecasting. That's probably not great, but there are other measures of forecast error which I will talk about, and we will actually calculate to see, did this work better for your particular data set then trend adjusted exponential smoothing. Significance F, probability that all of these should be 0. 0 is very low, that's what you want. Tells us at least some of these variables are important. We could go ahead and look at the p-values of the individual variables, tell us the same thing. There's a 1% chance that the intercept should be 0. Anything under 0.05, we would call it statistically significant. Sometimes 0.10 is a cutoff that's used, but no one would argue with you using 0.05 for a cutoff. The other thing we have is coefficients. These tell us what is the impact of these variables on sales. Intercept, just because of the data set that we have, this really is important for the forecast, but not particularly relevant. Basically, it says if all these variables were 0, you'd still sell 44 units, which of course is nonsense. But there was never a time in our data set where all of these were 0 at the same time. All of these coefficients. Guess what do we have here? Newspaper was given in thousands. This tells us a $1,000 increase in newspaper advertising increases our sales by 1.75 units per month. This tells us we hire 1 additional personnel. Our sales should increase by 3.6 units per month. This is very small. It says if we increase price by $1, we should sell 0.004855 fewer units per month. These are $10,000 to $12,000 items, so that makes sense. You could go ahead and multiply this coefficient by by say 1,000 and see what if. Let's just go and do that. Equals 1,000 times this. This tells us if we increase our sales price by $1,000, we would sell 4.86 fewer units per month. Same exact information, right? Just multiplied it by 1,000. So you could scale that up or down. What if we change the price by $100? Well, we'd sell about half a unit fewer per month. So it would have an impact. Let's delete that. Promo says if we have a sales promotion, we'll sell about 8. On average, we'll sell 8 more units. 95% of the time, a promotion would increase our sales between 3 and 13 units. Okay, so we can use, basically we're going to use this information, the coefficients, to make a forecast. Now, I said we already have some forecasts. These are predicted values of sales for the first 89 months. What we could do, let's go ahead and copy all that, all these predictions, and put over here predicted sales. We didn't use this. Let's just hide those columns out of our way. Okay, so you probably want to go ahead and do this. I will talk about forecast error. We'll have a couple other columns where we could calculate forecast error. We'll talk about that in a later video. These are our forecasts. Right? We would have forecast 26 if we had used this method in the past. Actually, would have sold 34. Okay. Now let's look at January, February, and March 09. How would we go about doing that? Sales is what we want to forecast. So this, we don't have data for that, so these will just be blank. What's the other column? Magazine, newspaper, personnel, price, and promo. Let's go back to the assignment file and it tells us which values to assume to make these forecasts. So newspaper advertising, 18, 5, and 8 for January, February, and March. So we're going to put that in 18, 5, and 8. That was newspaper advertising. If you'll remember, we did not include magazine in our analysis. So we could actually hide that column as well. Okay, what about personnel? We assumed 2, 3, and 4 average number of personnel. Sales price, 10,970, 11,570, 11,970. Promotion, no, yes, and yes. No is 0, yes is 1. So using these assumed values, we can make a forecast. How would we do that? We'll use the coefficients. We could refer back to the coefficients on our chart here. Probably easier. Let's copy. Let's go back to sheet 1, and let's paste these somewhere. Let's say right here. Let's not do it there because they have a hidden column. Paste them right here. Have our coefficients and what they mean. How do we make a forecast? Equals the intercept plus newspaper coefficient times newspaper advertising. Now that was F97 is a coefficient. If we would like to copy this formula down for January, February, and March, let's go ahead and click in the F97, hit F4, right, and then continue with our formula. Plus personnel times number of personnel. In the F98, that's where you copied it. Whichever letters refer to this coefficient, let's hit F4 so it always refers as we copy this formula down. You did this at the end for all three. Plus price times price plus promo times promo. And again, if it's referring to these coefficients, make it always refer to those. So this says we'd forecast sales for 29.72 in January. Get this little black arrow, our black plus symbol, drag that down. And there's some kind of an issue with my forecast because we forgot to hit F4 on the part referring to the intercept. So you might want to just type these three in separately. According to this, if this is how much we spend on advertising, have this number of personnel, charge this price, and have a promo or not, these are the sales we could expect. So these are our forecasts for January, February, and March. When it gets to calculating forecast error, we don't know actual sales, so we will not calculate an error for these times. Okay, you could calculate the forecast error for the first 89 observations, or you could use this one called residuals. Copy that, paste it over here. Residuals is the same as forecast error. You would get it by taking sales, subtracting your prediction. If you have a positive number, you under forecast. A negative number means you over forecast. And you could use these residuals to make some changes. Again, make sure you save your file with your name somewhere where you can access it. Send it to your email. Put it in a Google Drive. Put it on use Dropbox. Both of those are free services that let you save files online. You can access them anywhere. Or use a flash drive or something of that sort, or on your own personal computer to save it wherever you want to. Okay. And that pretty much explains the regression analysis part, making the forecast. Again, we'll talk about calculating mean absolute percent error for both forecasts at the same time because that's the same procedures regardless of which forecasting technique you use. If you have any questions, let me know.